Welcome to ClickMyProject.com. Now we discuss about the product for a balanced to unbalanced Microstrip power divider with the filtering function.
Now we discuss about the abstract for the product. Balanced circuit has been utilized more and more widely due to the higher immunity to the conventional noise and AC connections with other balanced circuit. Many balanced circuit has been reported, such as the balanced diplexer. Compared to the balanced circuit, the balanced to unbalanced circuit also a capability of to suppress the common mode signal, but the latter can be connected with a single-ended and unbalanced circuit at the same time. Example for the balanced to unbalanced diplexer. In the balanced to unbalanced filter, the balanced to unbalanced power divider is also the basic component of such as the application. Thus, the far a few papers about the balanced to unbalanced power divider have been reported. In this paper, the balanced to unbalanced Microstrip power divider based on the branch lines with several steps and the one resistor is proposed. The function of power dividing frequency selectivity of the isolation between the output ports of the common mode suppressions can be realized at the same time. The even and add equivalent circuits combining when the standard S parameter and the mixed mode S parameter adapt to derive the analytical equations at the center frequency. One or two transmission zeros can be achieved to enhance the out of band suppression. The center frequency bandwidth isolation common mode suppression by the design procedure to verify the theoretical prediction to fabricate the prototypes are designed and compared. This isolation of common mode suppression both prototypes are better than 15 to 20 dB within the whole passband respectively. To our knowledge, and no balanced unbalanced filtering power divider has been reported yet. Based on the reported frequency selective reported balanced unbalanced power, the feature of the frequently selective will occur only when one balanced filter or two single-ended filter are additional to added for required antenna model.
Next we see the flow diagram for the antenna design. We implement the antenna design using the HFSS software. This software to implement the high frequency synthesis simulator based frequency development and the bandwidth calculation to be all the designs and developments to be included in the HFSS software. So first we open the new HFSS software and new project design in our 3D model based designs. Then create a new project design. Then go to first we create the any one of the antenna. First we choose the substrate model, and to analyze the substrate model and the dielectric constant value and permittivity value and the dielectric substrate modeling type, all the things to be noted. Then we select and create the patterns for and the shapes for our substrate model, because example for circular or rectangular or square or triangular based substrate model used in our any one of the HFSS modeling designs. Then we apply the which substrate model to be implemented. Example for Roger or Roger 54003 or 5005. So then to apply the substrate model, then we go to the assign substrate material type. The material is represents the same like a Roger material, and we go to the patch model design. Whatever patch model we use, the circular, square or rectangular patch model to be implemented in our designs, and we using the polyplane for rectangular shape cut, all the things, and we add and subtract the implement design and to connect the what are the patch model implement in our secured diagonal patterns, and we implement the XYZ dimension based substrate model design in our secured selected new project. Then we go to the to design the bottom patch and top patch design. Every model consists of the ground plane and the top plane structure for our required patch wise designs. When the substrate to be included and the multiple substrate model and the 3-layer model and all the things to be designed in the first design based process. In every antenna design, we implement first the design phase completions process to be calculated. Then we go to the final design phase process. After design process to be completed, then we go to the analyze setup work for every antenna design. The analyze setup mainly focused by the boundary wise designs and the excitation wise designs in our field setup. Whenever you use the electrical field and we use the waveport model, and the magnetic field we use the step up port model for overall antenna designs. These designs to be applied for the frequency range. Then to set the frequency for a start and stop frequency and the solution frequency. The solution frequency to be changed based on the antenna model designs, and whatever we working the full bandwidth and to coverage with the center frequency range for our required solution frequency model. Then to set up all the frequency model and to run and the overall process. Then if the run to calculate the S parameter and it's like return losses for our required antenna design, then we go to the empty boundary box to be set up for the required antenna model design, and to set the radiation pattern. This radiation pattern to set the pattern wise model for our required 360 and 180 degree pi and theta value for setup for our overall radiation pattern. Then to calculate the radiation pattern graph and the polar plot graph and the gain level and all the things VSWR, each and every analysis for required antenna design to be calculated for our required model, final model. These are the final flow diagram for the antenna design process. Finally, we see the output for the product. This is the project 2 for our required Ansoft HFSS file. Just double click and open the HFSS software. These are the final model design to present in our overall filtering architecture for 4-band structure. These are the outer radiation boundary box. This is the Roger substrate material for our required model designs, and this is the perfect electrical conducting designs are placed for our overall structure. These are the final model for our overall structure designs. This is the 4-port designs for our required model. This is the 4-port for our required model. These are the overall designs. These are the final antenna design for our required balanced to unbalanced design for our required antenna model design. You just select that model design and to run and to simulate our required antenna model design. You just simulate. After we go to the results part, and you see the radiation pattern boundary for S parameter graph and return loss calculations for our required antenna pattern model. These are the final output for the process.